Hello everyone. We're going to do a bit of raylib today. So yeah, we've raylib's a very cool graphics programming, very simple, easy to get going. It's yeah, just a um, very great library, and yeah, we are going to program in C, just get it set up in C. So a lot of time in the past I've done some single header file libraries. This one's not a single header file. So we've got a couple of options. We can either vendor it into the project, or we could just install it into our system library. Or yeah, I'm going to show you another basically installing it into my home directory so I can reuse it. So yeah, let's just have a quick look at examples here. So we can look here, some window, and yeah, there's some. Basically, that's sort of the example we want to get up and running. Basically, just um, create a main program. We need the window, set the frame rate, set up a loop, and begin a drawing. And we might draw a rectangle or some text, and then we'll end the drawing. So yeah, let's get into it. So first thing is, let's just go over here. When I look for libraries, I always try and get to the source code. So in here you can see here there's a GitHub icon. So I'm going to go to GitHub so we can find the library source. So here are releases. Yep. So we could just like git pull it in and get the latest version, but sometimes it's nice just to have a stable release. So we'll go to releases here. They're doing a release here. So because if you're pulling the latest, that's fine, but then you might sometimes end up with sort of buggy stuff because they're still in development. But generally, the releases would be a little bit more stable. So latest release is version 5.5. So so we can scroll down here. You can read all about it, but here's all the assets we want. Now these are already pre-built, so I'm on a Mac, so I could just download this Mac version pre-built, but download the source code because I think it's fun. So let's copy that link, and yeah, let's have a go. So yeah, the way I've set this up, I've set up a folder, and I could vendor it into this project that I've just set up, but I'm actually going to install it into my system, so then I can use it in other projects. And yeah, so all I've got here is in my home directory, I've set up an OPT for optional software. And in here, this is like a normal install. So I've got a bin folder, an include folder, a lib folder, and yeah, a couple of folders. So, but in here, there's a source folder. So this is where I'm going to put all my source. You can see there I've installed a couple other libraries. Um, but what we're going to do is just get raylib from the repository. Just wait for that to download. So while that's downloading, let's set up a. So this is back in my I use NowVim today. Let's just set up a make file, and let's also set up a source folder and main.c. Okay, so let's just go see how it. No, download's still going. So yeah, let's just create an absolute basic hello world just to get everything started. I don't know why I put that there. Okay, so we'll just do a basic hello world. Welcome to raylib demo. Okay, so now we want to compile that. I'm going to do it as a make file. So first thing we want to do, I'm going to set up a build folder. So let's make a directory called build, and that will do for that. And we want to create an executable called demo, and the demo will need the build folder. Okay, so here we go. We're basically set up a make target. So this is the target file that we're creating, and this is the dependencies, and then below that is the actions. So in here, we want to make a build folder. So it's the file, which is the folder, and this is the actual action to make that folder. So now we want to make this demo application. The dependencies are the build folder, but also source the main.c. And to compile that, we can just go cc and let's put source main.c, and then the output will be build, and let's call it demo. Okay, so let's make, and you can see now that we have a build folder, and in there there's an executable called demo. Welcome to raylib. Beautiful. So now I can just yeah, I can run this from the root folder, build demo, and I can also go make ampersand. This will run that command, the make command, and build demo. So that'll be all in one go. It'll make the executable. Okay, so how's our download going? Looks like it's done. So you can see here I've got this 5.5, which is the name of the file I've just downloaded. So I can run tar extract verbose, and the file I want is 5.5. That should extract the tar file. And yeah, now you can see here I've got this raylib folder. Okay, so let's remove this tar executable, this tar file, which I don't need anymore. And I'll jump into the raylib folder. So let's just have a little look in here. Let's use new NeoVim. So this raylib is a very cool project. It's worth having a look at the source code. Anything that's open source, that's the beauty of it, that you can look around and browse around. But basically the way raylib works is you have this raylib.h file, right? And this here will have all the documentation of every function that you can call and use. So if we just go down to the functions here, so this is really all the documentation. So you could see there before we had the knit window function. And yeah, so that actually explains here what it does: initialize the window and an OpenGL context. And then there's close window, should window close, and you can just basically come in here and read these, look at the API and look what functions you've got available. So there's heaps and heaps of functions. And then if you're you want to actually know the internals of it, well then you want to actually go into one of the C files, and you can look at all the like R core, which is a lot of the functions in there. So you can find it and browse around and have a look at how it does stuff. So very cool way to explore the source code of projects. But what we're going to do, so there's actually a make file here, so we can use make, but since there's a CMake here, I think I'm going to use CMake today. So what we'll do, I'll just open another window here. So I want to build this, so I'm just going to, the way you usually build with CMake is you make a build directory, kind of like what we did with our make script. So we put everything in the build folder, so that all the build assets are just tucked away there, nice and clean. Now what we usually run is cmake dot dot. So we actually want to run the cmake from the previous folder. So you could see that essentially in that previous folder there's a cmake file. I think there is. Let me just double check. Yeah, there is cmakes list.txt. So basically one here, I'm going back to the root directory, and in the root directory, it's going to look for this cmake list.txt file, right? And now that will build it. But what I'm going to do, because I want to install this in a very particular location, so I want to install this in this OPT directory. So if I go back in here, I want the header files to go into this include, and I want the build libraries, the static libraries, to go in this lib folder. Okay, so what I need to do is pass in, CMake has this flag called D for a defined. So I'm going to define a variable, and the variable name is called CMake install prefix. Okay, now I want that to equal my home directory OPT. So I want to install this into the OPT folder. So this will now build me a make file. And it should have, yep, so we've got, you can see here now I've got a make file, right, that I can now run. So I can say make, and I've got a few cores on here, so I'll make with 6 cores. and we'll build raylib. And you can see there that it's actually, yeah, compiling raylib. It's all looking quite well, looking good. One thing about CMake, I must admit, the output looks very nice when you get lots of nice green text. Okay, so now I can run make install. Now this should install it into that location that I specified before. So it goes through, just checks that everything's been rebuilt, and then here we go, so it's installing. So you can see here now what it's installed. So I'm going to look at what it's installed. So I've installed this libraylib.a, which is a static library. So that's actually what I want to link with. And it's got the raylib.header file. So you can see this has gone into lib folder, and this has gone in the include folder, right? And there's also a RLGL file and a raylib mass folder. There's a few other sort of assets here that package config that we're not really interested in today. So let's just go back and check. So if we go into the includes, and you can see here I've got my raylib.h folder file. Okay, cool. So now let's go back to our project. So let's actually just check the library as well while we're going. And you can see here, so these are all the other libraries that I've been mucking around with, but you can see here we have raylib.a. Okay, so first thing I want to do in my main file, I want to include raylib.h. Okay, now you can see that instantly I've got an error. If I run make, build is up to date. Ah, there we go. I must have saved it. Okay, so you can see there I've got an error because it cannot find that. So I need to tell the compiler where to find that file. Now, the way I like to do this is there's a variable called cflags. I'm going to create a variable called cflags, and I pass it a capital I for the include directory. And the include directory is going to be my home folder, opt include. Okay, and if I put that here as well, so I'll include that cflags into my build. Now when it compiles this, it's going to look in this location for header files. Now, the good thing about this is now that this script here, these cflags, if I'm using other projects or I'm like looking for other libraries, like for example, in this opt folder, I had libvuv. If I was like linking, well, not the libraries, but if I was looking for include files, yeah, if I was looking for this uv.h file, or they're all there together, so I don't have to solo go and specify all these like lots of different paths. I can just all they're all sort of bundled together into this shared location in my home folder. So it's kind of nice. So let's make that now, and yeah, that worked, and I can run it, and it still works. Okay, but now when I go to call one of these functions, so the first thing, it's like the ID is just not quite updating. I might have to restart it just for it picks it up. Yep. It says file not found. Just oh yeah, okay. So basically my IDE doesn't know how to find these files, like where my search path is. So even though I'm running this in my make file, it's not sort of smart enough to look in this make file. But what we can do is create a compile flags.txt file. And what we do with that, we can echo the cflags and put them into a file called compile flags.txt. So I'm using NeoVim, and there's the LSP is called clangd. So clangd will look in this compile flags for any sort of flags that we specify. So basically I just want to reuse these C flags here in the compile flags. So now if I run make compile flags.txt, you can see there it echoed this variable, the include path, into the compile flags.txt. So if I look in here, compile flags.txt, you can see that now it will actually, I'm specifying to the compiler where to look, or not to the compiler, to the LSP, my editor. So now if I sort of restart it, it won't complain about raylib not being able to find it. So now let's try our function called init window. So let's create a window. Let's create a 800 by 600, and let's give it a name. So the title is like hello raylib window. Okay, so let's you should give me an error. So yeah, so it can't find. So it's trying to link it. When it's trying to link it, it can't find this init window function because we haven't linked it to the actual source code. So the actual the static library. So the static library was in this lib folder. So we need to link it to this lib.raylib, right? So the way we do that is very similar here. We can create another variable called libs, and we want to tell it where to look for libraries. So in this time, it's going to be the same folder, but instead of include, it's just going to be in the lib folder, right? So that's where it's going to search for libraries, right? And we'll just include that into our build lib. Okay, and let's make that now. Now that still will fail. So the reason is, so it knows where to search, but it needs to actually, you need to instruct to the compiler or to the linker what library to link against. So use the -l, the lowercase l. So the capital L is for the include path or where to search, and the L is for what to link against. Now we want to link against lib ray lib.a. Now, when you specify a library to link, it assumes that it begins with lib. So you actually don't need the lib, and you also don't need the .a. Okay, so we're just saying we're going to link with raylib. And then that should work. So let's build it, and we got a few more errors. Okay, so yeah, so this is now we've got yeah, we need to link to some of the Mac libraries, I believe. So let's go in here. Let's go back to raylib. I think on here there was a bit about how to link on Mac, working with Mac. So this should work. Raylib's cross-platform, so you should work on Windows, Linux, FreeBSD, all these different, so many different platforms. But I'm on a Mac, but if you're on different operating systems, just sort of pick, and just dive in there and find, what you need to do for your platform. And then eventually, like you could write your script that would run, you'd make a make file that would run on all different platforms, or you'd make a CMake file that would run on all different platforms. But in here, I think it will tell me. So yeah, it's sort of saying that you can install raylib using brew, but we've just basically installed it via the by compiling from the source. Um, this is it here. So you can see here, this is what we need to link to. So build a project. So what I'm going to do, I'm just going to copy this command here, and then I'm going to pick out the bits that I want. So you can see here, I need to like link with all these frameworks. So let's go back to our file, and there it is. So I am already linking with raylib.a file and the C file and all that. So we don't need any of that. So I'm going to delete all that. We've already got Clang. That's the CC bit here. This is Clang. Now, so let's just call this frameworks, or let's just add this to libs. So this is appending. So we're sort of appending here, and then we're appending more stuff there. So now we're going to link with all these frameworks. So we're Core Video, IOKit, Coca, Glut, and OpenGL. So let's see if that will work now. Oh, and it does. Very cool. So you can see that compiled. And now if we run our build demo, yeah, that worked. So you can see there this initialized raylib, and yeah, displayed lots of stuff. So All right, we're going to take a short break and we'll come back and finish off the compiling. Okay, so we're back and yeah, so this time we've got our we initialized our window and it's looking all good. We run it, we can see that we're actually running raylib, it's detecting our screen and all our devices. Now we just need to set up a loop. So while window should not close, and what I usually do is just go to GD, go to definition, window should close. You can see there that returns a boolean. So this will indicate whether the window should close. So if you hit the X button on your appropriate windowing system, but we want to say if it should not close. So that's why we've got the little not symbol there. And when we finish here, we probably should just close the window. Yep, that looks pretty good. And we should probably return this as a function that returns an integer, so we should just return 0, meaning all is well. Now, if you look at the raylib demos, let's go back to our raylib website. The best way to, like I keep saying, is to find these things out is just to read the documentation, go onto the website. But we go in here, basic window. You could just copy and paste this example, but we're just sort of copying. So you can see here, we got to begin the drawing. We then clear the background and then we draw some text. But we might, instead of drawing text, we might draw a rectangle. So let's have a go at that. So let's begin drawing. Right, and once again, it's just a void function and end drawing. Okay, and yeah, let's clear background. Now, clear background takes a color, right? Now, so you can set up your own color. You can specify red, green, blue, and alpha. But there is raylib does have some predefined colors. So let's just use red. So you can, if you go into there, once again, this is in raylib.h. There is like lots and lots of or not lots and lots, but there's a handful of predefined colors. Yeah, and if you want to make your own color, like it wouldn't be hard just to copy this and call it my color. This bit is sort of a macro depending whether you're in C++ or you're not in C++. We're in C, so we technically don't even need this macro. And we can define our own color to be whatever we want. So let's just go my color. Okay, and so now let's just run that. And there you go. Oh, actually, you can't see that. Yeah, just let me fix my OBS. Hang on a second. Okay, we're back. Sorry, I didn't have my OBS displaying my other program. So now when we run this again, you can see here we've got this nice red window with a nice background. So that's looking great. Now we can also, let's draw rectangle. So I often just type it out and then I go to definition. I can actually look at the definition and we can just paste that in here as a reference, and we can see that we take a position. So let's take the X position. Let's set it at 100. Let's set it at 100. And the width, let's do 300 by 400. And the color, let's go yellow. So we'll have a nice red and a yellow. Let's actually get rid of this my color and make it red. Make this my color up here. We don't need that anymore. Okay, so let's rerun that. And there we go. So we've got a yellow rectangle with a red background. And yeah, so I mean that's it really. We've set up raylib. We've got it drawing a window where we can draw a rectangle. But obviously, like there's so many functions here, and the best way is just look into this header file, the raylib.h file, and you can look at all the different functions. You draw pixels, draw lines, circles, ellipses, rectangles, rings, triangles, right? And then you can get into some more advanced drawings. But then there's like lots of other stuff, collision detection, loading images. Um, yeah, there's just like so much. Yeah, fonts. We can draw text. And yeah, I believe you can do you can even do 3D stuff now in raylib. So there's just so much. Sound. There's lots of sound. So you can basically make a full blown game. Sort of gives you all the building blocks ready to make your own game or your own little fun little application. So um, yeah, that's it. So yeah, hopefully you enjoyed the video. If you did, give it a like, subscribe to the channel, and yeah, if you like this, we'll hopefully make some more content. Okay, see ya.